Chapter 5, Section 3, Master. We're still factoring trinomials, but in this case, we're going to consider trinomials where the number in front of the x squared is not 1, which we did see in the last video, but you're going to notice very quickly with this example, 3x squared plus 11x plus 6, that this is a little different. We say, oh, well, 3 is a bit of a problem. Well, let's factor it out. The problem is we can't because of this term here, this 11x. 11 is not divisible by 3, so you cannot factor out this 3 from this trinomial. In fact, there is no GCF at all that we could factor out other than 1, which is completely redundant. So you might think this is not factorable. Well, it turns out it is. We just have to be clever about it. Here's step 1. We need to look for our two magic numbers as we did before. We just have to look for them in a slightly different way. Since we can't factor out this 3 has to play a part in choosing the two numbers that we're looking for. And it's here. This says positive 3 and positive 6. So in order to factor this trinomial, we need to look for two numbers that multiply to 18. Where did 18 come from? It comes from multiplying 3 times 6 mentally. So we just do that in our head. Okay? But we need two numbers that add still to this middle term. So that hasn't changed. So remember before, we were looking for two numbers that multiply to the last but add to the middle. Okay? In this case, we're looking for two numbers that multiply to the product of the first and the last but still add to the middle. Okay? I know it's a bit of a mouthful, but I'll do a few examples for you. But what's the answer to this question? What two numbers multiply to 18 and add to 11? 9 and 2. Okay? The fact that we found these two numbers means, well, we're home free. Step 2. Now it comes time to actually do the factoring. And there are two methods here that I'm going to show. Method 1 is called decomposition, which basically means to break down. And method 2, that's just a quick and dirty shortcut. So I'm going to show both. And I'm going to begin by writing the trinomial from above as it was originally given. Okay. But what I've done here in this line right here is I've broken the 11x into two pieces. Well, what two pieces? Well, I didn't find those two numbers above for nothing, 9 and 2, because 9x plus 2x is still 11x. But why did I break this middle term into these two pieces? Well, now we can factor by grouping, which is something that you've seen before. All right? So, look for the greatest common factor between these two terms. Well, I can factor out 3x. Okay, so that would leave here x plus 3. Okay, and next, look at these two terms. What's the GCF? Well, I can factor out a 2, and that's about it. And that would leave x plus 3. And notice, lo and behold, these two binomials are the same. Right. Which means I can factor out x plus 3. And then I get 3x plus 2. Okay, so this stuff you've already done before. Okay, the only thing that was really new was starting from 11x and knowing to break it down into 9x plus 2x. But this factoring by grouping is the same. Let's check it though. Let's FOIL it out. And I'll write it down one more time. Okay, so first, outside, inside, last. And it's not a coincidence that 2 and 9 show up again. But when I combine the like terms, I lose those two numbers. So I just get the 11x. So finding those two numbers, 9 and 2, is about being able to go from the expanded form here to the factored form here. So this matches what I originally had. Therefore, this is correct. Okay, what about method 2, the shortcut? Okay, well, this is a shortcut in that it's quick, but it doesn't really explain what you're doing and why. It's just a way of getting the answer faster. All right. Well, we still have to do the work from the previous slide, and that is determine the two numbers that work. Okay, 9 and 2. But unlike the decomposition method where I had to break it down and factor by grouping, all I'm going to do is the 3x squared. I'm going to write the 3 twice, okay, in both sets. And then I'm going to write an x and an x. And then the numbers 9 and 2, I'm just going to put them in as is. Okay. Now the only thing left is to look at each term in here and divide out any common factors that we see. So between 3x and 9, I know I can divide everything by 3. And between 3x and 2, well, there are no common factors. So really the only thing I could divide out is a 1. So what do we get when I divide 3x plus 9 by 3? This gives me x plus 3. Because 3x over 3 is just x, and 9 over 3 is 3. And anything divided by 1 is just itself. Okay? And you notice I get the same exact answer here. So again, this doesn't really explain why. It's just faster. Factor 6x squared minus 5x minus 4 using both methods. That is decomposition and the shortcut. Well, first we look for a GCF. Okay, it'd be nice if I could factor out the 6, but unfortunately, there are no common factors between 6 and 5, and 4 is smaller than 6, so there's actually nothing I can do. Okay. So I have to look at the product of the first and the last, which is negative 24. So in order to be able to factor this trinomial, I need to find two numbers that multiply to negative 24, but add to negative 5. All right. Well, how about 12 times negative 2? Okay, well, if I add those together, I get 10. So that doesn't work. If I reverse the signs, remember, because the answer has to be negative, okay, that just changes the sign of this. I want negative 5, so those numbers are no good. How about 6 and negative 4? Okay. Well, add those together, you get 2. Changing the signs, that's not really going to help us. Okay, so we just keep looking. And 8 and negative 3 would multiply to negative 24. Add those together, I get positive 5. Oh, so close. I think this is the only adjustment needed. Negative 8 times 3, yep. And add them together, yep, perfect. All right, so those are the two numbers. Whoops, I don't want that. Those are the two numbers that we need. So now we can actually factor it. So we begin by writing out the trinomial, but instead, this middle term, I'm going to break it into two pieces. Okay? But not just any two pieces. I'm going to break it up according to these two numbers here. So it's 6x squared minus 8x plus 3x minus 4. Okay, again, if I was to combine these two terms, I would get negative 5x. But I want to break these down so I can factor by grouping. Okay, so look for the GCF here. I believe that is a 2x, which leaves 3x minus 4. Okay, look here. Well, there is no GCF other than 1. Well, that's the best I can do. And remember, when you're factoring out a positive, you must put the sign here. Don't leave it blank. Well, this is good. I want these to match. So I can factor out the 3x minus 4, which leaves me with 2x plus 1. And you could FOIL this out and check, but I'm pretty confident that it's correct. So that's method 1. I'm going to show method 2. Okay, so this was method 1. Method 2. All right, so method 2 assumes that it is factorable already. Well, we know it's factorable. So we go immediately to the double brackets. And the first term was a 6x squared. So I write the 6 twice, and I give an x to each of them. Okay? And then all I do is I put the two numbers in here that I found in my table. So you still have to do this work. You still have to find those two numbers. So that was minus 8 and positive 3. Okay? Not quite done. I need to look at each set of binomials, and I have to divide out anything that the terms have in common. So between a 6x and a negative 8, I can divide out a 2. And between a 6x and a 3, I can actually divide out a 3. Right. So dividing each term in here by 2 gives 3x minus 4. And dividing each term in here by 3 gives 2x plus 1, which of course matches this. Okay. So choose whichever method you like. I leave that up to you.